Back on statistics, I taught you one lesson on statistics and then used the rest of that time working on your draft assignment. That's the only big assignment that you've got this year, because the other one was that quadratics thing that you did in class. So really you should be noticing that the level of difficulty will go down for the rest of the year until I start trying to give you a head start on year 11. So the last thing we spoke about when we were on the timeline work was discrete numerical data. That was data that you obtained by counting. I count the number of siblings you have. I count the number of pets you have. I don't measure that. So the next type of numerical data, the only other type of numerical data we have, is continuous numerical data. We obtain that by measuring things. For example, your height. I don't count your height, I measure it. It's different to discrete data because discrete data takes specific integer values. Can someone remind me what an integer means? If I say an integer, yep, a whole number, good. Continuous numerical data is different because it can take any value within a range. You don't have to be exactly 150 centimeters or 160 or 151 or 152. Your height can be anywhere between about 150 to 200. If you're a giant, obviously more. I'm just going with the average height of human beings. And it does not need to be whole centimeters. Why is it important to distinguish between continuous numerical data and discrete? Because the type of graphs for discrete data would not work. For example, if I tried to do a dot plot for height, it might look something like this, and this is incomplete. That's not going to fit our class's heights. The x-axis would be ridiculously long because I need a space for every... And I've only just decided that I want to go to 1/10 of a centimeter. That's just an arbitrary decision. Do you have to be exactly 1/10 of a centimeter in height? No, it just depends how accurate you want to go. So do you agree if I did this fully, that x-axis would be really, really long? And also, very few people are going to be exactly the same height. So the graph is just going to look really sparse. There's going to be some dots here and there. And is there going to be any usable shape if your graph looks like that? Just going to have some random, there's not going to be any usable shape whatsoever. And then also, I'm roasting this. What if someone was 160.45 centimeters tall? I don't have a space for that. Okay? So hopefully this illustration shows you why we can't use the graphs that I've shown you about discrete with continuous numerical data. It doesn't make sense to. So this is where you start getting the notes for class intervals. From the above example, it should be clear why continuous data needs to be treated differently. Continuous numerical data needs to be divided in class intervals, which are ranges of numbers written like this. Can you have a look at this and tell me why I would go with 0 to less than or equal to x, x is the data, is less than 5, why that would be proper versus these class intervals in red. What is wrong with that?
If it's saying like greater or smaller than 10, then you're never actually accounting for a value being 10.
Yes, exactly. Where does 5 go in this data? Because this class interval is anything between 0 and 5, but that's between 0 and 5. 5 is not going to fit here. It's also not going to fit there. But do I know exactly where 5 is going to go in this set? Because this is saying that it's the data, 5 is less than or equal to the data and then is less than 10. So this 5 would go in here up to 9.9. 10 would go in the next one, okay? Why not these class intervals? 5, 10, 15, where do they go? So, if you could please, can you get that example of proper class intervals there? And then the note about there should always be 5 to 10 class intervals to ensure graphs have a meaningful shape. If you only divide it into 2 class intervals, you're not going to get a graph that has any shape whatsoever. So get that example of notating class intervals. You don't need to get the red down because it's wrong. Do you need something to write with?
Oh, I should be fine. I have stuff pencil either way. Oh, there it is.
Clubs.
Just that box on the left, and the fact that there should be 5 to 10 class intervals. Yep, question? Oh, no. All 4 pencils today. Pens. If you need that again later, I'll go back to it because what's important today is demonstrating this. Can you shush, please? If you're going to teach it, you can come up here and do it. Then we can record you and chuck you on YouTube yourself. The data should also be put into a data table indicating the class intervals instead of individual data values. Please be aware. If I've arranged my data into class intervals like this, have I lost information or have I gained it? I've lost it. So if I knew my data was 0, 1, 1, 3, right? Before, I would have known that I had 2 1s, 1 3, 1 0. Here, all I'm going to know is I had 4 numbers between 0 and 5. I've lost specific information about it, okay? Please be aware of that. Now, I don't know if people know their heights. Do you know what your height is? What's your height? Do you know? Okay, quick, come up here. Do you know what your height is? Just
189.
Come up here, I'll measure it.
Oh shit. Oh. 191.2.
I'm just going to go centimetres.
I don't know.
After thingy, no names. Okay, quick.
Yes, Solomon.
What is your problem? I'm recording here. How hard is it to not name people? You're meant to be Ignite. Jesus. I'm not going to be able to reach this problem. 187. Oh, you know? Do you know it? No. Do you know it as well? No?
Oh, like 170. I don't know.
Okay, come. You three. Ow! I didn't call for you. Sit down.
It's my hammy. Sorry, I found my hammy.
I'm doing this because this is a demonstration of collecting real data, okay?
No idea.
Yeah, come. You know? Yep. Start getting that table down because I want you to be able to chuck it into class intervals. We'll do it live. Do you know?
170.
Sorry?
170.
170. Do you know? Do you know? You know? Come on. Do you know?
167.
Oh, get close. Get that table down, please, as we do it. Yep. Do you know? Come up. Do you know? Come up. Do you know? Come up. Do you know? What?
170.
Yep. We don't do half. We don't do points. I think that's everyone. Can you get that table down, please?
186 feet.
Start having a think about it now while you're copying that down. What would be the most effective approach to deciding the class intervals? I need between 5 and 10 class intervals. Yep. How would you approach it?
Intervals of 5.
Yeah, that's good. You're skipping to the answer. But like before, you're doing that actually in your head. But what is it important to decide to start off with? Yeah.
Identify the total, like the range from the lowest to the
Yes, that's why I have to look. What's the smallest height that we've got here?
158,
158. What's the tallest we've got?
187.
I think there's one higher.
191.
Oh, yeah.
191. So we're going 158. 158 to 191. What's the difference between those?
33. So that'll give us 7 categories if we do it in 5s.
Yep. That's how you think about it. Or you could just do the difference between those numbers, divide it by 5, and then you'll know how many things that you need. So I'll start doing that now. We'll start off at 155. Less than or equal to the height is less than 160. 160, less than or equal to the height, less than 165. 165, less than or equal to the height, 170. 170, less than or equal to the height, 175. 175, less than or equal to the height, less 80. One more. We need to fit that last one in there. 190, less than or equal to. Does that meet our criteria of the right number of class intervals?
Yep.
So, someone remember what the point of the tally was?
So you can count as you go.
Yeah, count as you go, because I'm not going to remember the frequency off the top of my head. So I'm thinking of numbers between 155 and 160. No. 1. And that makes the frequency easy. 1. 160 to 165. No. Is there any? No. So is 0. 165 to 170. We've got a nice proportion of them here. 165 to 170. No. Yes. 1, 2, 3, 4. 170 is in the next one. So 4, 5, 6, 7. I count 7. 170, 175, So it's a little hard. I'm not actually showing you how to use the tally properly here because I'm having to shift between one side of the screen to another. 170 to 175. 1, 2, 3, 4, 5, 6, 7, it looks like, again. We got the extremes in this class. 175 to 180. No. 1, 2. I count 2. 180, 185. 1, 2.
The 185 doesn't count because it's in the next category. It's 180, but in
Oh, yes, you're right. Sorry, my bad. 1, 2, 3. I count 3. I'm going to zoom out so you can. 185 to 190. So thank you for that correction. 1, 2, 3. I count 3. Last one. The tall people. 190 to 195. No. 1. I got 1. Yeah, that table down, please. We're going to use that to draw our histogram. Oh. Copy. I'll move on. All right, frequency histograms. The only appropriate graph for continuous numerical data, like we've shown today, is a frequency histogram. What is special about this? It looks like a column graph, but what do you notice about the bars? They're touching. There's no gaps. Why? Because that represents the continuous nature of our data. We don't know whether it's 0, 1, 2, 3, 4, and 5. We just know that we had this many between 0 to 5. We had this many from 5 to 10. Okay?
you could break it up further and it would still
You could,
retain its shape.
yes, exactly. So if you broke it down into more class intervals, you are still going to see, can anyone remind me where we had more data on the low end? Was that positively skewed or negatively skewed? Positively, it's the opposite of what you think, okay? So maybe just do a spiel about what's a frequency histogram. It's a column graph with no gaps. Draw a real rough diagram of that. Please notice the scale points are on the edges of the blocks. So the block between 0 and 5 would be for the class interval. 0 is less than or equal to x is less than 5. I'll linger on this for a couple of minutes. And then I want to graph our class data. Our class data is going to look so weird. There's going to be no shape to it whatsoever. Oh, mate. There'll be a little bit. We got outliers. I would be one of those outliers. If I spiked up my hair, 180 centimeters. We'll do the example real quick, another minute, and then I'll show the example using our live data that we collected. Sorry, what's up?
No.
He's just waiting. I'm not worried about it. He's great.
Is it still recording?
Huh? Yep. You hadn't said any names. It's fine. All right, I'll quickly do the example. Using the class height data from above, just resize it. So we need 7 class intervals. Draw a frequency histogram for the class height data, which is the modal class. Can someone remind me what the mode was? Was that the average?
The middle.
Was the No, median was the middle value.
Ah,
Mode. The most common, the highest frequency, yep. Draw a frequency histogram, what's the modal class? Describe the shape of the distribution of the data. We can answer the modal class straight away because which one is the highest frequency class in... Oh, we got... There's 2. So the modal classes are... It's bimodal. 165 less than... to 170 and 170 less than or equal to H. So we have 2 modal classes. There's always a chance because we just got the data. Yeah.
Since they're neighbouring, could you just say 165 to 175?
I guess you could say that, but we already decided that the class intervals are broken up into 2. So just to be safe, we say it's bimodal. We've got 2 of our decided class intervals being equally the mode. Drawing it up, what do you reckon this little sort of heartbeat thing might represent? Are we starting from a height of 0 here?
No.
So if you ever need to indicate the x-axis is cut off at some point to show that you're skipping over a bunch of numbers, then just do a little disconnect there. So what would our class intervals be? 155 to 160. 160 to 165. So draw up a similar graph if you need. 165 to 170, 170.
I thought because it was a histogram, you label each of the dashes as 155 and 160 to 165.
Yeah, at this point I'm just trying to get it drawn, right? Because I'm not even writing the class interval properly, but at your level of ability, I think you get it, what I'm trying to show. The point of me doing this is like, when I ask you to do something, I always demonstrate. I will do what I've asked you to do, not be a hypocrite and be like, just do this. I'm showing you how it's done. 185 to 190, 190 to 195. That's going to cover all of us. There is one person, so up to here. There is no one, 160 to 165. There are 7 people, 165 to 170. There are also 7 people, 170 to 175. There's 2 people, 175 to 180. So you can see I'm just doing the dots to make it easier for myself. 180 to 185 is 3. 3 again. And then 1.
Yeah, but does the 170 count here? Yeah, because it's...
The wave is... That's so bad. There we go. I'd colour in if I had time, but I want to get to the last bit of the question. Describe the shape of the distribution of the data. Number 1, is there an outlier? Is it a legitimate piece of data? So it can't be ignored. You cannot be ignored. Okay? That exists. We can't say that wasn't an error or anything. That's how tall this person was. However, it's still an outlier. So is it part of the general trend of the data? Let's look at this block. So we acknowledge its existence. It's not an error, right? But when we're talking about the skewness of it, we're mainly looking at this set of bars here, right? And where is there more data in our main trend of data? On the low end or on the upper end? On the low end. So you would conclude that this is positively skewed. Right?